Okay, so we're going to try to make one of these old aircraft radar altimeters work again today. Just to go over what we have here, there is this horn antenna. It looks to be about S-band, although the frequency is not indicated anywhere. This is the indicator. I believe this is some sort of a servo thing. Not quite sure how it works, but we'll give it a try. I bought this set because it has an octal plug for the back here, and has these plugs, which I have as well. So here's one of the radar units. And then this one right here. And this one has a Feb 15, 1981 date on the module. This is a March 15th, 1982 date. And although the case is dated April 77, this one the seller said that it worked. The seller told me this worked. I'm sure this will work just fine if it's, assuming it's not full of water or something. And then the other seller sold this one as is. So I bought two of these, so I figured I'd make one of them work out of the two. And look at the hour indicators. It's hard to tell. I think they're just pegged past 1,000 hours. And then there's this thing here, which was pulled out of an aircraft working. So what we'll do is take a look at the manuals and see how these things go together, and power them up and see what happens. Okay, got the screws off this one unit here, and we'll take a look. Oh man, look at that. That is awesome. This is entirely made with point-to-point wiring, and I don't see any ICs whatsoever. All discretes. Wow. This is definitely cool. This thing, this appears to be some sort of, might be a gun oscillator front end, so I wonder if that's the bias control, and perhaps a mixer diode right here, and a varactor. I think it's something like that. So I would guess bias, varactor, and mixer be my guess as how this works. So there's your front end, and yeah, it's definitely cool. Actually, this could be the mixer here. Hard to tell. I've got to dig into this a little bit. But yeah, that's definitely the inside. It's a nice piece of equipment. Okay, so here is the inside. So I removed the back cover, as well as the front and the knob here. And you can see, interestingly enough, there's actually a wire, actually kind of like tuning cord for a radio, that rotates this entire assembly around. Wow. And it seems that when the needle goes through, this is an optical, looks like an optical isolator here. The needle goes through there to set the alarm. So you set the needle, it passes through this optical isolator, and there's some sort of alarm that will go off. Here's the lamp brightness adjust. I assume that's the lamp. And yeah, this is definitely cool. There's actually an IC over here. Looks like an op-amp, single, like a 8-pin dip. A lot of rework and hand point-to-point wiring. Some more little can op-amps right there. Yeah, wow, another whole pile of point-to-point. It's quite the construction. It's a very nice unit. A lot of handmade, a lot of hand assembly here for this. Okay, so now that we've seen the insides, I'll have to take a peek at, see if we can power these things up, get them to run again. Okay, so I ran into an interesting problem with the movement. This movement was getting caught up here, and now it's running freely, but I had to unscrew this little pivot here, and I removed the pivot, dipped it in one dip, swished it around, and then I put some watch oil in there, and placed it back, and got the needle steady, but then the needle's getting stuck on the bottom here, so I unscrewed these two screws and moved this plate around. There's very little clearance on this needle, so it's getting stuck. So I fixed that, so now it's free to run. So hopefully it should go all the way up to 2,500 feet when we turn it on. Right now there's no signal, and once this thing gets settled in, what I've seen in the past is the needle will come up all the way. I think that's from my fans that wind there. Maybe it only comes when you hit the test switch. Test switch, see it does. Well, no matter, we'll keep working on it and see if we can get it to do the right thing here. Okay, we're going to try this thing out. I think I've got it fixed now. So, as it turns out, the center contact can't make connection with the chassis of the meter, so I had a short, so I fixed the short. The meter is free, the needle's free to move. So if we turn it on, and we give it a minute to warm up, or whatever it's doing, you'll see that it'll think that we're at maximum altitude, 2,500 feet. After a minute or so, or whatever it takes, it just kicks all the way to the top, because there's no signal, so there it goes. So it assumes, actually this isn't the way, so it assumes if there's no signal that we're at the maximum altitude, which is pretty cool. So I think the next thing will be to, right now I've got a dummy load right here on the antenna, so I think the next thing is going to be to button this part up and start playing with this antenna and see if it can measure anything. Okay, I've got the case back on. Let's give it another try. Again, the dummy load is here. So power on, and let's see if he ends up going back to if he goes to maximum height. There we go. Cool. So we're above 2,500 feet. All right. Next, let's see what it does when we connect the antenna. This is the spare unit that I'm not sure if it functions or not. So I'm gonna get the spare out of here. Okay, let's hook up this antenna. Point the antenna this way in a random direction. I'm not sure what it's going to do. Okay, let's give it a shot. Power on. So it says 2,500. I don't know why that's the case. have an antenna on it now. It should be giving us ranges, but it's not going to read out 40 feet, that's for sure. Ah, here we go. Okay, it's giving us erroneous. Okay. Doesn't surprise me if it's confused because we've got weird stuff going on. A ceiling fan over here, all kinds of crap. So it drops to altitude hundreds of feet, so 100 and some odd feet. So I've got to take it outside, play with it. It seems to be reacting to the environment though. That's a good sign. Here's the radar altimeter, all placed on, it's been mounted onto a slab of wood, and you can see we have the indicator here, the transceiver, and the antenna system, and it's ready for test. So we'll see how this one goes. Should be interesting. Okay, I'm going to take this big trihedral corner reflector and walk backwards with it and see if this thing tracks me. Here's the trihedral. Track me. This should present a massive target for this thing. Okay, start at 0. Alright. Start walking backwards. Too close, it should go crazy. Alright. Let's take a look at that. Okay, here's the spectrum of the radar altimeter, and they should be sweeping. It's a little hard to tell if it's sweeping or not. Usually if we do like a trace max hold, you can kind of get a feel for if it's sweeping. Zoom way in. Over time it'll fill in. Yeah, I think it is. So if we go to marker, it seems like it's kind of it's sweeping from about here to here. The output peaks at about 16 dBm, plus perhaps a dB and a half of cable loss, maybe 2 dB of cable loss, and 4.2 to 4.3, so maybe 80 to 100 megahertz of bandwidth. Alright, so I finally got this radar altimeter to work. And we have a graveyard of old radar altimeters right here. This is the working unit. There's the indicator. Here's a couple more indicators that have had problems. This unit is broken. I have a pulse generator there. I've got that pulse generator is modulating this SIGGEN. So what we're doing is we're actually feeding in RF in here, and then I measured the output with a detector, and this is actually a pulsed radar altimeter. It has about 35 microsecond interval, pulse rate interval, and you know, it's 16 watt peak pulses. It's a pretty wild system. So and it also has 700 volts. It's a tube-based system actually, and there's 700 volts present right there. So we'll turn it on. There's that voltage. And then once it dips, we'll know we're in. There she goes. It's dipped. And at some point, we should be able to. There she is, 500 feet. Actually, hard to see. Let's see here. Okay, we're at 500 feet. I'm going to try to set the camera up right here to watch that indicator while I adjust the delay. Actually, before I do that, I've got this pulse gen set up so I can adjust the delay here and change the altitude. And the output from the SIGGEN is minus 20 with 40 decibel attenuation, so it's minus 60 dBm. And then here's the video output. So we're triggering down here, and that is this is the pulse from my signal generator. So let's see. Let's get this thing going. All right. So now to vary the delay, it simulates a target. We can increase the height, the altitude rather, decrease it willy-nilly. And this indicator's servoed, which is really cool. It's kind of hard to hear with my heaters going. And of course, for this range of delay, the pulse generator has got limited movement. Let's see, we'll go up here and crank it all the way to maximum height. Pretty sweet. Yeah, it's a really nice system. Actually, I'm gonna peek the response here. Okay. And let's see at what point does it lose lock. We're still locked. Okay, minus 75 dBm, still got it. Okay. So it looks like around minus, I'm still locking my 70 at minus 74 dBm. So that's pretty sensitive. Crank it up a little bit so it's stronger. So that's it's a very sensitive receiver on this thing actually. It's pretty good. And here it is, pulsing away. I've actually measured the output power and the output spectrum, so I know the transmitter's going. Right now, the transmitter trig is right there, so we're synced. This is triggering the pulse gen, which is driving this guy. So we're synced to the transmit trig. And I've set rigs up like this before to test pulse radars. It's pretty simple, but this thing's definitely working. It's sensitive. The problem with me testing it in my lab is that I'm just picking up too much clutter, and so it sees nonsensical readings. Therefore, the best way to test it is like this, in a conductive test, unless we're flying it in an aircraft, which we don't have. You know, the ground return is pretty bright and it's very distinct when you're in the air. There's no other clutter to confuse you. And when you're measuring time of flight, let me turn off the other channel, like we are here, clutter will be a huge, huge problem. So that is the, oh, by the way, I'm hooked up to the video output, which is given by pin B over here. So that is the radar altimeter. Again, I'll show you the data sheet here, where it tells you 16 watts peak, okay, at 4.3 gigahertz. Looks like the receiver is peaked at 4.25. Of course, this is an old SIG-Gen, so she's probably off a little bit in accuracy, and this is probably off a little bit in accuracy too. Alright, so here's the graveyard again of radar altimeters. And this thing is definitely working.